Hello everyone, my name is Paolo and I'll be discussing different network communication concepts I learned from Bit 121. So let's begin. I'm going to start with one of the types of encoding. So first, let me discuss what is encoding. Encoding is the process of converting data or any given sequence of characters and symbols into a specified format. So it could be digital to analog or analog to digital. And there are several methods of encoding. We have the NRZ, the NRZ inverted, and for my report, I decided to highlight the differential Manchester method. So what is differential Manchester? Well, it is a type of encoding scheme that uses the presence or absence of transition values to indicate the logical value of the signal. So it uses that technique to indicate whether a particular signal will be expressed in terms of one or a zero. So what are its advantages and disadvantages? So for the advantages, it is less prone to error compared to other encoding schemes because it is self-clocking, and it is also less affected by noise since the only thing that it considers is the presence or absence of the transition codes that is embedded in the signal. And then for the disadvantages, it uses an extra bit for the transition codes, and it's a little more complicated to implement compared to the other encoding schemes that I mentioned earlier. And moving on, another concept in network communication is multiplexing, also known as muxing. So it's a technique of transmitting several data signals over a single channel. And there are several multiplexing techniques. So there are space division, frequency division, time division, polarization division, orbital angular momentum, as well as code division multiplexing. And for my report, I would like to focus on the time division multiplexing technique. So it is a method of transmitting multiple digital signals over the same channel. And it's relatively simple in circuit design because it uses the whole bandwidth. And there must be proper synchronization between the transmission and the receiving stations for it to work. And another thing to note for time division multiplexing or TDM is there are two types. There's synchronous and there's asynchronous TDM. So for synchronous TDM, it is a technique wherein a time slot or packet is pre-assigned to every source. So in this technique, each source is assigned a time slot irrespective of the fact whether the source contains data or not. So if the source has no data, then it will remain empty. So for synchronous TDM, signals are sent in the form of frames. And then for the other type, the asynchronous TDM, or also known as statistical TDM, it is a technique in which a time slot is not fixed, as in the case of the synchronous TDM. So time slots are allocated only to sources that contain data to send. And asynchronous TDM dynamically allocates time slots to sources if they have data to send or not. And in this technique, time slot that contains an address is part of the source of the data. And what are the common applications of this particular muxing technique? So it can be seen as applied in cellular radio, GSM, public switch telephone networks, as well as digital audio mixing systems. And then moving on to another concept in network communications are errors. So since transmission of data is not 100% perfect and guaranteed, it is prone to errors. And some of the errors that we can encounter are single bit errors, which means that only one bit of the transmitted data is changed from a 0 to 1 or vice versa. That's what we call a single bit error. And then for the burst error, this type of error means that two or more bits of the transmitted data are changed from a 0 to 1 or vice versa. And since errors can occur in data transmission, we do have several methods of detecting errors. So some of them are the simple parity checks, the two-dimensional parity check, checksum, and cyclical redundancy checks. So that's it for part one of my report and video presentation. Thank you all for your time. Hi, welcome back everyone. So I've opened up my VirtualBox Manager, and as you can see, I have two operating systems installed, Ubuntu and Microsoft Edge, I'm sorry, Windows 10. So I'm here to discuss about bridging NAT as well as other forms of virtualization in terms of network communication. So for the VirtualBox, it's pretty easy enough. As you can see, if we click on Windows 10 and go to Settings and Network, by default, the network type is set to NAT, or Network Address Translation. So basically, this means that this virtual machine and the host network share the same network identity, and the virtual machine is not accessible from the outside network. That means if we try to ping the Windows 10 that's installed on the virtual machine, we are unable to do that on our host computer. So basically with NAT, it transforms the private IP address that we receive from the ISP or the internet provider, and it lets all the devices that's connected to that internet use that particular IP. So let me see if my Windows is already running. Hold on. So yeah, I already did an IP config. So as you can see, for this virtual machine, my IP address is 10.0.2.15. And then if we go to my host computer and I do a IP config, we'll see that the IP configuration is 10.0.0.90 for my host machine. So with that, you can still surf on the internet on this guest machine or the virtual machine. So if we try to ping, let's say Google, so we are receiving packets. So we can even test it out on our browser. So yeah, so we are still connected even though we are using this particular network address translation. So this basic configuration should be enough if we want to let our guests surf the internet or download files or check their emails. So it's ideal for small businesses or home use when we are using this method. And then for the other type, which is bridge mode. So basically for bridge mode, the virtual computer has direct access to an external Ethernet network. So it treats the virtual machine as another device that's connected to our home internet network. So the DHP server of the network assigns the virtual machine an IP address. A bridge network adapter shares the host's physical adapters, which implies the adapter joins the network setup like any other physical system, like my phone that's connected to the Wi-Fi or other people laptops that's connected to the same internet. So it's viewed that way. So it's with Bridge, it allows for greater flexibility, and also network maintenance is easier with a Bridge network. Plus, network congestion can be reduced because we are dividing a LAN connection into small sections. So for my Ubuntu OS, so I'll show you my VirtualBox settings. So for this, as you can see, if I go to network, it's set to bridge adapter. And then if I open up my terminal for my Ubuntu, and let's say I do an ifconfig, so you'll see that for the IP address, it is assigned 10.0.0.44. So meaning this is the IP address that's assigned by my home network to this particular device. And comparing that to the NAT, which we mentioned earlier, which does not allow external access. So let's say we ping the IP address of our host computer. I believe that's 10.0.0.90. You'll see that we are actually able to communicate with our host computer. And same vice versa. If we ping this particular uh, this particular computer using our host computer. I believe that was 44. I believe the IP address of the Ubuntu computer is 10.0.0.44. You'll see that it is able to communicate to the Ubuntu system because it's using a bridge connection. So, and that's basically some of the methods of setting up network using VirtualBox. We also have the host-only method, wherein the host-only method establishes a network connection between the virtual machine and the host system through the use of a VPN, and that is accessible to the host operating system. So with host networking, the virtual machine can only communicate with other virtual machines connected to the same host-only network or via a virtual switch. And to create an isolated and secure virtual network, we can use that particular method. Welcome back, everyone. So I would like to show you how we can use FileZilla to transfer files between our host computer and our virtual machines via FTP server. So as you can see on my desktop, I've already installed the FileZilla client. So let me just open this up, and then I'm going to go into my VirtualBox. So this is my Ubuntu virtual machine, which is a guest. So let me just open the terminal. And in order for us to be able to use the file transfer via FTP, we need to ensure SSH or Secure Shell is installed. So I think I already have that on my Ubuntu OS. So let me just type my password. So as you can see, there weren't any new files installed. And then to enable the SSH program, you just need to type sudo systemctl enable SSH, and then just start the secure shell sudo systemctl start SSH. So as you can see, I've created an FTP folder on my desktop in my Ubuntu OS, and it currently doesn't have any files. So we'll go back and switch to my host desktop, which is a Windows 10. So first, we need to enter the details here. So we can do a quick ifconfig on our Ubuntu OS. So as you can see, the IP address is 10.0.0.44. So that's what I will use. And then my username is, as you can see, Paulo. Then I'll just enter the password, and by default, we can use port 22. Just hit quick connect. So you can see that this are the files on my virtual machine. So this one is we can see the folders in my Ubuntu operating system. So if we go into desktop, and you can see this is my FTP folder. So let's say I wanted to copy these 3 files from my Windows folder into my Ubuntu folder. So we can just select and drag it, and then so you can see it refresh in real time. So we were able to successfully perform an FTP transfer using FileZilla. And that's it. Thank you all for watching.